Assalamu alaikum everybody. Today we are going to discuss about a very popular topic, sentiment analysis. We are going to discuss into details of how the sentiment analysis is implemented from the technical point of view, and also we'll look into how many data scientists in this area are working to improve and make it more useful for the businesses. Okay, so let's start. The natural language processing is a focus of research in data science these days, and one of the most common application, as I told you, in NLP is sentiment analysis. From opinion polls to creating entire marketing strategies, this domain has completely reshaped the way the business works today, which is why this is an area where data scientists must be familiar, and many of them are working diligently to improve this technology, this area of NLP. Thousands of text documents can be processed for sentiments and also for different other features, including named entity, topics, etc., in seconds, compared to the hours it would take to a team of people to manually complete the same task. Today, the world is generating huge data electronically. The transformation of this data into knowledge is very crucial, and the area which helps us into converting this data into meaningful knowledge is known as KDD, the knowledge discovery in databases. So same process applies in the case of sentiment analysis, where we have some data, we select some target, out of it a pre-processing step is performed where data is pre-processed, and we'll talk about it later on. Then transformation of data is performed, some data mining techniques are applied to it to extract the important information. Then using machine learning algorithms we can extract knowledge, and in this case the sentiment of people who are expressing or writing the text. So what is data mining? It is a process of discovering interesting knowledge from large amounts of data stored in a database, data warehouse, or other information repositories. And sentiment analysis is a subset of data mining. Okay, the data is generated per minute in today's world is very huge. You can see here that we generate 2.5 quintillion bytes of data every day. That is 1 exabyte. That is, of course, you know that it's 10 raised to power 18 bytes. So it is coming out to be something like 2.5 billion gigabytes. So you can imagine how huge it is. The sentiment analysis has become a key tool for making sense of that data. This has allowed companies to get the insights and automate all kind of processes. And if you look at today's data which is generated, our lives are filled and surrounded with data of all kinds, and data never sleeps. So if you see in statistics, you can see here that the data generated per minute in last year, that is 2019, was also very huge. And you can see that, for example, if you look at YouTube here, you can see that YouTube is producing 4500 videos per minute. If you look at Twitter, it's more than 5 lakh tweets a minute. If you look at Instagram, then it's 55 more than 55,000 photos user post every minute. Google searches more than 44 44 lakhs. And there are other also the Netflix. If you look at the Netflix, then you can see that 69444 videos were there in a minute. So you can imagine how much data is produced. Anyway, so let's continue now. Scope of sentiment analysis in the research are, we have different levels based on task, the levels, approaches, and the data types. If you look at briefly one by one, the task has polarity analysis, subjectivity analysis, emotion deductions, and sentiment of strength. Then at the level, the word level, the phrase level, the sentence level, and finally the document level. And if you talk about aspect-based sentence analysis, then it's the word level. This word level is the one which shows you what is the aspect present in a data or a piece of text. Then we come to approaches. So we have different approaches: the lexicon based, the machine learning approach, and the hybrid approach. Normally nowadays researchers are using hybrid approaches to uncover the sentiments. And finally the data types. So we have microblogging data, that is the data we can get from the social media networks like Twitter, Facebook, and so on, and also the conventional data, you know, already present in many repositories around the world. Okay, so what is sentiment analysis? Basically, we are dealing with the process of computationally identifying and categorizing opinions expressed in a piece of text. This piece of text can be obtained or extract from a social media network, as well as it can come from any news website or any website where users are giving their reviews about their product or service. In order to determine whether the writer's attitude towards a particular topic or a product is positive, negative, or neutral. So we can see here that the main categories are positive opinion or sentiment, and a negative opinion sentiment, or a neutral opinion sentiment. Okay, so here are a few examples. Like you can see here that your response time is really bad. I've been waiting over a month. So this, as a human, we can interpret very easily that it's a negative statement or a piece of text. And if you look at this review, the customer support is amazing, love how the platform works, so it's a positive sentiment. So what we need to do during the process of sentiment analysis is to find out the words which are showing some aspects, like response time. It is this, in this piece of text, it is clearly indicating the response time is bad. So what we need to do is actually be able to extract this word as a feature and this word as a sentiment. So you see again in this piece of text the word amazing, that is related to the customer support. So the customer support is the aspect amazing is the review or the opinion of that person, and from that we should be able to label it as a positive sentiment. Now let's see this graph where you can see that the interest in the term sentiment analysis has been immense, and you can see it has been steadily rising. This was for the year up to, I think, 2000, beginning of 2019. For the last 5 years worldwide, the people were interested, and gradually this interest were increasing because of the technological improvement in the hardware also. So as we are getting faster and faster CPUs and the computers, the machines, we are able to extract information from big data. That is why people are getting very interested in this and other areas of NLP and of course machine learning. If you look at this, you can see that Pakistan is placed on the 6th. Country wise, different countries are working on this area, which shows that this technique or this field of research has been extensively followed by researchers and other academic persons in Pakistan also. If you go to Google Trends and type the word sentiment analysis, you're going to find this graph which shows that still this area is continuously being explored and people around the world are working on it. And if you go to the bottom of this, you can see that China, Singapore, Ethiopia, Nepal, these are the countries which are working on this. And here we see Pakistan on the 7th. I've just run this search, and you can find very interesting information like the topics which are being searched are bag of word model, must have heard of it, and if you are working with on Python, you know NumPy and other thing. And the related queries are aspect based sentiment analysis. You can see is coming right now at the second number in the searches. So if you look at the search term data mining, then again you can see it has a very continuous interest in it. And if you look at the areas where this has been followed, so you can see with the dark color you can see different countries. And if you want to see where Pakistan is standing, so it's on the 6th number. And a lot of work is being done in this field. Okay, coming back to the levels of sentiment analysis. The levels of sentiment analysis defines as centered on earlier research work done by the scientific community, and we have seen different levels like document level. Document level is defined as a classification of document that expresses a completely positive or a negative opinion on an object. And if you see here that sentiment analysis can classify the total polarity of a product review given by a customer, it is assumed at this level that the sentiment classification that one document carries opinion about a single object only. So this is one assumption which is done when you are working on a document level. And for instance, a customer review of a specific product as a result of a sentiment analysis can have a maximum of three outputs, as discussed earlier: the positive, negative, and the neutral. So this is at the document level. Okay, at the sentence level, the sentiment, opinion, polarization of each sentence is determined as either neutral, negative, or positive. As the sentences are considered a kind of a short document, so there is no major difference between the document level and the sentence level. It comprises of two parts that determine whether a sentence is an objective sentence or a subjective sentence, and if it is found to be a subjective sentence, then determining whether it states a positive, negative, or a neutral opinion. Okay, as discussed earlier, the sentiment classification at document or sentence level is very useful in many cases, but are insufficient to provide necessary information needed for various applications because they do not identify sentiment targets or assign opinion to those targets. That was the shortcoming which we normally find in those previous two levels, that is the document level and the sentence level. So the aspect level sentiment analysis achieves finer grained exploration that is needed. Some other names for aspect level are entity level or feature level. We normally know it as aspect based sentiment analysis. If you look at this example, the battery life of my IQ mobile cell phone is excellent, but its display screen is very small. So you can see that this particular sentence or a document, technically we have two things, two features on which there is opinion present, and that is the battery life and the screen, which are basically the aspects of Q-Mobile. The simple methodology of the mining aspect is to by finding nouns and noun phrases occurring frequently. This is what we are going to see when I'm going to go through a example. I'll tell you how it happens. You must have heard about POS tagging, so that thing is used here to find nouns and noun phrases to identify the aspects, and then after the aspects are identified, the text can be labeled as positive, negative, or neutral. So if you look here, the aspect based sentiment analysis, few examples you can see here that the battery life is terrible. If you go for aspects that are also known as features, the sentiment present is about the battery, which is negative. As you can see that the label or the word we are getting for it is a negative word, that is terrible. Another example, the screen resolution is grade A. Grade A is identifying a positive sentiment, so the aspect display screen is positive. And another example, this laptop computer's battery is poor but the screen resolution is great. So the sentiment analysis model should be able to identify these two aspects, that is the battery and the screen, and should also be able to identify these two words as their opinion for that particular aspects. In this case, the battery is negative and display screen is positive, as we are getting word poor for battery and great for screen resolution. Some of the real life use cases are social media monitoring, brand monitoring, voice of customers, customer service, workflow force analytics, product analytics, market research analysis, and there are many more applications which can be included in this list. If you look at this table, you can see that there are many different areas in which this is divided sentiment analysis. We have approaches like lexicon based machine learning approaches. If you go on the left towards the lexicon based, then we have corpus based approach, the dictionary based approach, then statistical approach, and semantic approach. Normally nowadays statistical approaches are very popular, and on the right side there are machine learning approaches such as supervised learning, semi-supervised learning, unsupervised learning, and on the left you can see we have many different algorithms such as decision trees, classifier, linear classifier, rule based, where SVM and naive based, and these are other classifiers which can be used. And if you go for supervised, you can see the k-means, the KNN, agglomerative, diversive, DB scan, and hybrid clustering. So we have many different methods available which can be used and applied. And normally, as I told you earlier, that hybrid methods are normally applied, which is a mixture of all the matter. And as a data analyst, you should know this, that every data set has its own characteristics and have their own features, so you have to apply different models to extract the best out of it. Okay, now I'm going to show you how this whole process of identifying aspects and assigning labels of positive, negative, or neutral are done. Very briefly, not in detail, as there is a restriction of time. Anyway, so what we need is a data set, and normally we have data set which are available readily at different repositories, and you can also extract data from Twitter or Facebook or any social media of your liking. Then if you look at this, your screen, you can see there are two columns. One has label, that is the class that has been annotated to this particular text, and on the right side you can see the text that has been extracted from the social media. And the first thing you need to do is to see and try to observe what is happening. I mean, what kind of sentences you are dealing with, what kind of data you are dealing with. So if you look at the social media data, you will find a lot of words which are not properly spelled, and also you are going to find a lot of links and other data which is not very useful for your analysis. So you need to just get rid of all that junk. Like you can see here, this does not make any sense and it's not going to help you in your analysis anyway. So these are few things which you need to observe and identify, because like this txt, the tags and all that, you need to remove them during the pre-processing step, and that I'm going to do a bit later. And if you look at this, these are the sentences and the labels have been assigned here. And ham and spam, I am sure you know about it, that hams are actually the emails which are important to you, and the spams are basically advertisement and all that, which are not very important. So what we are trying to do here is we are trying to classify these two as ham, I mean these text sentences into two classes, the ham or spam, or you can say a positive or a negative, as discussed earlier. you can put a positive for ham and negative for spam also. So this is just an interpretation anyway. So what we are going to do here is we are going to just get the pre-processing done. It's called data pre-processing and cleaning. And if you look at these two images, you can see on the left the data which is represented as an office here has all the files lying on table on the floor, and they are not properly organized. So finding a particular piece of information from this office is going to be very hard and time consuming, and you might not be able to get it in time. And on the right side, it's a very clean, organized office, and everything has been in place. So if you want to look for something, some kind of information on a piece of paper, or you just go there, you know where it is. So this is like that, the pre-processing step, in which you clean your data to make it more accessible and useful. So you are searching for a document, and if you have a document which is cleaned and pre-processed, then extracting information and placing it in a particular class is going to be very easy. Okay, the pre-processing of the text data is essential step, as it makes the raw data ready for mining. That is, it becomes easier to extract information from the text and apply machine learning algorithms to it. If we skip this step, then there is a high chance that you are working with a noisy and inconsistent data. The objective of this step is to clean noise those are less relevant to find the sentiments, such as punctuation, special characters, numbers, terms which do not carry much weight in the context of the text. Okay, for example, you have extracted data from Twitter. So what you need to do, or during the processing step, is to remove handles that are marked as this, and due to privacy concerns, so these Twitter handles are hardly giving any information about the nature of the tweet, we know that. And we can also think of getting rid of punctuation, numbers, and even special characters, since they wouldn't help in differentiating different kind of tweets. Most of the smaller words do not add much value, for example PDX, his, all, so we try to remove them as well from our data. Once we have executed the above three steps, we can split every tweet into individual words, and those are tokens, you know that, which is an essential step in any NLP task. And so this is how we do it. In a tweet, there's a word love. We might also have terms like love, loving, or lovable in the rest of the data. These terms are often used in the same context. If we can reduce them to the root word, that is stemming or using lemmatization, then we can reduce the total number of unique words in our data set without losing significant information, which is also a very good technique, as it is going to save a lot of CPU time and processing time and give results faster. In the next step, we can understand or analyze the words present in the tweets, and for that we can create word clouds, which are a very useful way of finding out which are the words which are very commonly or frequently used in your data set. A word cloud is a visualization wherein the most frequent words appear in the larger size and the less frequent words appear in the smaller size. So we are going to apply that and try to see what kind of words we are getting for different so this data set which was applied here. Okay, these word clouds are very useful way of analyzing and finding out which words are very popular, frequently used in your data set. So we can see that the word people, today, week, smile, love. Look at the size of the the more frequent a word is used in your data set, you will see it with a larger size font. And the smaller words like positive, affirmation, march, work, these are the words which are not frequently used but are there in the data set. If you look at the other example of only positive words, you will see that time, summer, smile, love, happy, these are the positive words or appearing in a positive context. And for the negative words, you can see white, black, hate, Trump, racist. These are all the words which are showing you the negative emotions. I don't know about the Trump, but it is showing you the negative emotion. So So, after the pre-processing steps, you should be able to identify the words which are present in your data set. And for example, you should be able to have information like the size of the data set, the polarities which are present, the positive, negative, or neutral, and also how many sentences are positive, negative, or neutral. In this example, we have a data set named Twitter airline data set, and it has like something like more than 14,000 tweets in it, with 2363 positive tweets, 9178 negative, and 3,000 neutral tweets. There was another data set which was prepared during our research work, and the gold standard data set was produced, and it was named data for TAPSA, and it has 2703 tweets with 1734 positive tweets, 224 negative, and 745 neutral tweets. And this was the data set which was extracted from Twitter and pre-processed, and it was about the telecommunication companies of Pakistan. So these are some graphics you can see on the right side, and different tools you can use for analysis like R, Python, and also you can use RapidMiner for statistical analysis and mining of the data. Okay, the basic idea is to, after the preparation of the data set, you will be splitting the data set into two parts. One will be the training and the other will be the testing data set, and the ratio normally uses 80-20, 80 for training and 20% for the prediction or the testing. And for supervised learning or unsupervised learning, the basic idea is you have an input where features are extracted, and those features are fed to the machine learning algorithm, and a model is prepared, and depending upon the ability of that model, when prediction is done on a separate data set, that is a test data set or unseen data set, the results are labeled accordingly. So if you have a very defined and well made model, machine learning model, then you will have you can have accuracies of more than 90% on your data set. Even if you are using a naive based model and you are processing your data set properly and you have enough data, then you should be able to get more than 90% accuracy very easily. Okay, framework which was developed during the research for the aspect-based sentiment analysis. I'm going to quickly go through it, and you can see here that the input are the tweets that can also be real time. Then we have this pre-processing step. I don't know if you can see it properly, but I can read it, so you should also be able to read it. So the process steps the tokenization, slang detection, spelling correction, lemmatization, stop word removal, pure stagger, and identify of emojis. We have included the emoji part also in this research. Anyway, what we are dealing with is on the left side, that is the TF-IDF or the document level methods are applied. Then on the left side you can see that we have a word list which will automatically add the new words which were not present earlier, which were not seen earlier by this framework. Here we have a process to identify idioms or phrases, which is again a very big task in NLP, and the word embeddings, where I'm sure you have heard of it also. It's a very interesting and exciting technique. So this was also used, and after all the feature extraction and negation identification and other processes, a machine learning model were used, and in that we have ensemble technique used, and we applied different algorithms. We can see here the SVM, the naive Bayes, the bag of words, and sorry, the bagging and the boosting algorithms. And then we have a sum of weighted votes, and there was a algorithm at the back of this working which will identify the final polarity of a tweet, and that can later on be stored. The results can be stored and seen on the monitor. Also, we have included emojis to identify the text, because normally people are using emojis to express their sentiments instead of writing words. So we have included that also. That also produced a lot of good results in this research. Anyway, we were able to identify more than 2300 emojis, about 8000 plus slang words which were normally used in the social media, and then these were used for supervised classification to capture idioms and phrases. I've already told you about word sense according to the context and expect identification process, the term frequency inverse document frequency, and then ensemble methods, in which we were able to get better results. The methods used were, as I told you earlier, the naive Bayes, the SVM, bagging, and boosting, and they were used in an ensemble configuration. Okay, here I'm going to show you a walkthrough example, and I'll explain every step briefly, obviously, how we were able to identify aspects, as I mentioned earlier in this discussion. So we have some tweets here, and they have been pre-processed. As you can see, there are 15 in total for this example, and you can see these are all from the data set which were prepared about the telecommunication companies of Pakistan, and official handlers were used to extract this data. Anyway, we have a data, a text, good luck, with an emoji. Thank you, Mustafa, so glad that you love the Telenor experience. Then we have this, we apologize for troubling experience you face, network issues will be resolved. You can see there are numbers missing, 1, 4, and you can see here that 9 is also missing. What we have done here is that we have already applied one process that is called the identification of sentence, which does not carry any sentiment. So we have removed the sentences in the previous step before this. So the remaining tweets are the one which with all the which do have some kind of sentiment in it. So we are going to try and extract it, and the next step you can see that we will be removing the objective tweets, and we will be only considering the subjective tweets here. And for that you can see that 1 2 3 4 were removed as they were only objective. So we have some sentences here. We apologize for troubling experience you face. Network issues will be resolved. Told you need to get a new connection from different cellular networks, and all these. Never get drop calls. Never in spot where there is a poor reception. So then we'll be doing a part of speech tagging for the subjective tweets, and you can see, and you must have studied during this course, the NLP course, how this is being done. And this is used to identify the nouns, verbs and adjectives and so on. So this is the way you identify your words of interest. And then if you move further, you can see in the fourth and fifth step we were able to identify the nouns. You can see on the left side in the list with their frequency, like service. The word service has appeared 5 times, network appeared 2 times, and so on. And if you look at the right side, this is the similarity score which was produced for the recurrent noun. Recurrent noun are those nouns which are continuously appearing. And as I've told you, this is the data set about telecommunication companies and their customers. So we were able to identify many recurrent nouns such as experience, network, issues, connection, service, customer. So you see, these are all the words which are related to the telecommunication industry. So we have some similarity score. Then we use the k-mean clustering to cluster words. Network, call, connection rate, phone, data coverage were given one cluster, and the customer, year, money, service, plan, issues were in the other clusters. And these are the clusters which are selected for further processing. Remember that we are trying to identify the aspects here in this process. Then you can see the aspects: the call, connection rate, phone, data and coverage. These were the common aspects which were identified during the previous 6 steps. And after this k-mean clustering, we were able to identify, and then we see here the never get drop calls. So call is appearing here. This is an aspect. The connection is appearing here. The rate, the phone, the data, the coverage. These are the words which are appearing in these 6 tweets. Then next step, the aspects and their polarity. The calls in the first tweet, the never get drop calls, so it is a positive sentiment. So, and you can see here, never in spot where there is a poor reception. So the word poor is being used, but it is used in a negative way, so it becomes positive here also. So if you go and see, the calls are showing a positive sentiment, the connection, the negative sentiment, rates, phone, positive, data negative, and coverage also positive in these tweets which are here. And if you read these words, you will agree with this results. So the thing is that we were able to identify the aspects automatically using the techniques which I have mentioned earlier, and also using the techniques of machine learning, we were able to label these and predict the polarities as well. And briefly about this emojis, emicons used in the analysis. So as I told you earlier, that nowadays we are in the world where emojis are very popular and people express their sentiments using the emojis. So these are some results after after using and including those emojis with the processing before assigning the final sentiment to the text. So we were able to get uh, results which were more interesting. Okay, this was the results which we obtained after the process, and you can see the name of the networks, the Mobilink, the Warid, Ufone, Telenor, Zong at the bottom of your screen, and these are the negative tweets about that company. Then we have some positive and the neutral, so we have different uh, number of tweets about a company and the sentiment polarity of those tweets. And you can see that Ufone has the most number of positive tweets for them, uh, as you already know that it's one of the popular company in Pakistan. And then we can go further and see uh, the precision recall and the F scores used in this research were also interesting and encouraging. And if you know about these statics, then you should be able to see here. Then this we were able to achieve 95 F1 score, 95 point something F1 score. And if you compare it with the state of the art, you can see that we were able to be in the top methods. So thank you very much, and I hope that you have learned something from this. And if you have any questions, you can ask, and I'll be happy to answer all the questions. Thank you very much, and Allah Hafiz.